Welcome, guys. Couple things I thought I'd make a video about. First of all, this is going on, so just I just found people talking about on Twitter and retweeted anything that was different at all from people. So, the scientists discover a leak in the bottom of the ocean. This probably has the paper. This probably has the paper. The paper. This paper, which we can even kindly, thanks guys, download. I already downloaded it, but essentially fluid sources and overpressures within the central Cascadia subduction zone revealed by a warm, high flux seafloor seep. So let me find it here. This is not the totality of it, but this is one of the places apparently. I think I posted a video. Here's the phys.org one. This video. So according to phys.org, essentially everyone talking about this is like, if I search for mega 6 times, where is it? I don't see it. Mega thrust. The mega thrust fault zone is like an air hockey table. If the fluid pressure is high, it's like the air is turned on, meaning there's less friction and the two plates can slip. If the fluid pressure is lower, the two plates will lock. That's when stress can build up. Pythia Oasis, which is where this seeping is coming from, which they've named it. They literally named it that. Newly discovered seafloor seep. In the paper, they just name it immediately. But provides a rare window into processes acting deep in the seafloor, and its chemistry suggests this fluid comes from near the plate boundary, said co-author Deborah Kelly, a University of Washington professor of oceanography. This suggests that the nearby faults regulate fluid pressure and mega thrust slip behavior along the central Cascadia subduction zone. So let's check out this video. Like, it's just boiling up, this fluid. Venting. Just venting. I mean, certainly there's hydrothermal vents, but I guess this is differentiated. It's new, it's newly discovered, and I think not only newly discovered, but it's new. Like, they searched this area before, and then going about their research, they noticed it, I guess, and then ended up writing a paper about it, it seems, because it was probably pretty concerning. Like, when they saw the change, I think it changed. I haven't like 100% verified that it changed, but the way people are talking sounds like there was some change. Let me look at the paper. Where focus venting emits highly altered fluids approximately 9 degrees Celsius above the background temperature. The seep fluid chemistry is unique for Cascadia and includes extreme enrichment of boron and lithium and depletion of chloride, potassium, and magnesium. We conclude that the fluids are sourced from poor water compaction and mineral dehydration reactions with minimum source temperatures of 150 to 250 degrees C, placing the source at or near the plate boundary offshore Central Oregon. Fluid rates 10 to 30 centimeters per second are orders of magnitudes higher than those estimated elsewhere along the margin and are likely driven by extreme overpressures along the plate boundary. Probable draining of the overpressured reservoir along the vertical Alvin Canyon fault indicates that the important role that such faults may play in the regulation of pore fluid pressure throughout the forearc of central Cascadia. So even they sort of suggest over extreme, they use the words likely driven by extreme overpressures along the plate boundary. Sounds like earthquake related. Everyone's talking about it earthquake related. Honestly, I don't see how it's not. Let's look at maps. They said 50 miles east of Newport, Oregon. Newport, Oregon. 50 miles east. So if we look here, Newport's here. Notably, it's like right, generally in line with this corner. I don't know why that would matter particularly. But anyway, it's 50 miles off the coast. So if we just go measure something around here, let's say, pretty much around where the continental crust starts to dip down and just sees like the boundary of the continent. Basically, it's boiling out the boundary of the continental crust. So that means it's sourced from over here, like underneath the crust, and is flowing out this way by pressures from this side. So my thought is, like, let's imagine that there are layers that stack on top of one another. Sometimes they're continuous, there's no gaps. Other times they're more like chambers, like a cave system that then has layers on top of it, but then like the pillars can break and the layer drops like a building collapsing, and it can like hit the next layer, break that layer until some equilibrium emerges. So like it's possible if we look around here, like if pink is a support structure and blue is a non-support structure. So like notice there's a support structure along this coastline. Even though there's all this blue, there's this support structure here, here, and then again along the coastline, just outside of the coastline. So there's a support structure right along this boundary that's really defined, which makes the boundary really defined, presumably, compared to over here, where there, if we look, like down in Baja, California, there's a support structure, but then as we approach California, that support structure is actually down the middle of the state. So if you imagine that there's a table with legs on every side and you press down on the side of the table, it's still stable. But if there's a table with like legs down the middle of the table and you press down the side, it's gonna stress it. And so like it's almost like an overhang. That's literally how I view all of California here, is like it's almost overhanging with some support structure, but certainly not. Like here's one. Like not that much compared to the rest of the world. Like also here, no support structure here whatsoever. It really makes me think of also like this. Honestly, I'm a little concerned. I'm not gonna lie. This is like almost. I almost want to be like, warning, get the fuck off the West Coast, dudes. The somber face here. Like, this could physically just be like, and collapse with a lack of a support structure here. or down here somewhere. I mean, so where Newport is, I believe, is around just over here. So it's coming out over here in this region. Maybe it's boiling out and bubbling out from this general region. Let's find coordinates. Let's say this coordinate right here. 44.66. I do like that. 125. 44.65. 125.0. So it's pretty much right there. It's seeping out right there. And generally, so if we look here, there's kind of like a resistance. So if any current's coming down this way, it can like run into resistance here somewhat. So maybe it's venting like because there's building up in this region of whatever is venting that is generally low, being sourced from some other location, maybe through here. I mean, this literally could be where it's sourced from. Like, if this is having pressures downward, things are starting to push down, then it's kind of like something falling. It's going to displace the air below it, but it's just falling so slowly that it's just starting to create subtle effects. Like the fall it's begun. Maybe, I don't want to say the whole region is falling into the ocean. I'm just saying, like, maybe the earthquake is something of that nature. And there really is no support structure down this. It's really more like a top of V. I mean, it's still supported by walls. It just doesn't have a support structure here. So if you like imagine a huge rock with a bunch of weight that really would benefit from having its weight resting on something, but it's just not here. And then there's all this rain and water etching through the rock over time, and human inhabitation. I don't know if that really adds relative any amount of weight or influence, really. Maybe like if there's oil or something in the region that's being siphoned out from under, just to basically anything that's holding up this mass to prevent it from falling down. If we remove any of that pressure, it's gonna just have less pressure holding it up and more likely for it to fall down, and to do so drastically with like literally like breaking apart into components. Like, it could physically be one thing, like one continuous thing that snaps in half and kind of slopes down with like something here. I'm not saying that's what's going to happen, but like it literally, because there's no support structure to the continental crust itself. And even if we look out further, let's look at this. Like, the crust doesn't stop at the coastline. What needs supported is really out here at this boundary. Then this is kind of probably past the support structure that's present at all, or and maybe not the support structure, but past the layer that's one. Like the continent is like one unit, relatively speaking. But like components can break off. Like a rock can have pieces break off. But because it's moist and has all the like characteristics necessary to keep it alive and like uniform and not like brittly breaking, it maintains. But like there's certainly equilibriums that depend on circumstances, and in this case right here there's a support structure, and then it seems to wrap up generally around this way. I mean, how big are we talking here? It's not that big. It's Really just not even, just Olympic National Park. That's interesting. Olympic National Park is in this crevice. Mega Quake Olympic National Park. Let's see if there's any discussion of a threat relating to. They mapped one. They mapped. No discussion of a mega quake. Mega quake. Oops. Pacific Northwest. The most prone locations. Mega. Saying Cascadia. I guess what is the boundaries of Cascadia? Boundaries. Goes up into British Columbia. But certainly includes Olympic National Park. Cascadia Subduction Zone includes it even. ETS zone. I don't know what that means. Earthquake, tsunami zone? Something? How are you gonna have ETS zone and not... fuck. Because I took the image somewhere, I guess. Episodic tremor and slip zone. It does seem to follow here. It's almost like when it has a support structure like this, and then it's atop it, and then it like snaps kind of like next to it, and if the support structure is not just like a straight thing, it's more like angled maybe, so it can fall down and like connect at new points to lead to like a tendency maybe for earthquakes, especially adjacent to the support structures, where it's felt like that because the regions further away from the support structures have bowed into the depression where they lack a support structure more, they're just more stable maybe. Maybe. Earthquakes. Let's see what's up. I saw this one happened. Or no, not that one. 7 days for that one. There it is. Let's maybe do 7 days, 2.5. So it's April 13th there. April 14th, 16th, 17th, 12, 11, 13. So earthquakes along the Juan de Fuca fault line or whatever this is called. I think it's the Juan de Fuca fault line, pardon me. Fuca, fault line. Juan de Fuca Ridge. And maybe Ridge. But it looks like there's traveling, like whatever's coming around this way is then going down here and then through out into this region rather than through here. Like it's literally going down here and then through here. Maybe through these really carved channels. Not like the center point, the thick part, but through the blue parts where it's really deep in blue, which means it's like space for the current to flow into maybe, which just encourages it more through this region. Maybe when it comes around this way. Like currents that are flowing generally from over in Asia this way. Going up through here, as well as maybe through here, even across this way. Just generally making their way over here. They don't end up going so much over here. They end up going more along this southern boundary, relatively speaking. That's interesting. Right through the chakra. Right through the chakra. 12. 12. A little later. Another hour later. 11. Through the chakra. Where's the chakra? Here's the chakra. Wonder if energy from over there gets in through the chakra more so, and through this chakra. Maybe that's why there's chakras. There's like an actual channel inlet underneath it. A channel inlet underneath it. This, and then a third chakra here. That doesn't seem to have... Where did I do it? There it is. Chakra, chakra. Less of a chakra. That one's got a pretty distinct inlet though, right there. And over here, I guess. So there's actually multiple chakras, maybe, forming on this one. Another chakra. I don't know if that's like 100% like anything unequivocally happening or anything, but it seems plausible here. Okay, 24 minutes. I'll probably stop this soon. I just mostly was like, this is kind of crazy, dudes. This whole area is at risk. I mean, really from about LA, maybe not so much San Diego, but even there. And maybe even down here, so really all the way up. The whole western coast of North America is concerning right now. I've made multiple videos talking about just the sheer amount of rain that California is getting, making me think of some kind of exchange process occurring, as well as adding weight and stress to the region that, again, might be kind of just hanging over there. And you just put weight on it, and I mean, it's a continent, so it's not like that breaking, but like, hey, never know. As it approaches like an instability point, it might just start to have like processes happen, like weather patterns substantially anomalous and changing, like all the snow and rain they've been getting. And then this thing opening up here. And then just the somber face here. I mean, I almost feel like it's written in stone that this is gonna be a tragedy, like, sooner or later. I'm not saying now, but sooner or later, there's gonna be that mega quake, and it's gonna be a tragedy that will explain why there's a somber face. Happy news, huh? See you guys soon. Next one, yeah. Right? Do I want to go? Actually, real quick, I won't make another video about this. I'll just talk about it real quick. Just wow. So from this, I took a clip of it. Pardon me. Incredible. It just looks like maybe a goat or something, more, but a sphinx. It looks like a sphinx, but like carved naturally by current flows. It's so cool. I just had to point that out because it's so cool. This is from Amazing Places on Our Planet YouTube channel. From Taiwan, the Yao Liu, Yay Liu, that place, Geopark, northern coastline, lots of cool features, not just this one, just everything there is cool, lots of cool stuff, like what? This video is real good for cool stuff here that I hadn't seen before too. Lots of cool stuff. Oh, these slopes are interesting. Whoa, it's like... What? I didn't notice that. Oh, shit. This place is incredible. This has got so many different, unique things, like a shallogram. It's like shallogram level of incredible. What? Like, what? They're just like little nubs. Whoa. I thought it was a spiral at first. Just cool. Just cool. So cool. Layers, very cool. So much potential too to like really learn. Oh my god. And then the Sphinx. Alright. So till next time guys, I'll see you soon. Peace out.